The combine feature in Fusion is used to modify bodies. Basically, you identify a target body, which I have here. I'll hide the tool body so you can see that the lower cube is going to be my target. And if I hide that, you can see that the upper cube is going to be my tool. So when you go into combine, you are asked to identify both a target body and a tool body. Again, the target body is the one that's going to be affected. The tool body is either going to be merged or used as a cutting surface on the target body. So let's go ahead through all of these operations. There's basically three of them: join, cut, and intersect. So if I select my target body, the lower one, and I select my tool body, I can do a join of the two. Let me just go ahead and do that. And now you see the tool body was deleted, and the target body, if I hide and show that, is the merger of the original two bodies. Okay, so let me go back to that same feature by right-clicking on it in the timeline and selecting Edit Feature. And one little tweak here is I'm going to click on this Keep Tools. So everything else is the same. Target and tool bodies are selected. The operation is still join. And I'm going to click OK. And now we see we still have both bodies here in the browser. If I hide the target, you'll see that's the original tool. But if I hide the tool and show the target, you'll see that that's one big combined body. Okay, so that was join. Let me go back and edit this feature again. And we still have the two appropriate bodies selected. But let's now do a cut, and I'm going to keep the tools. We're seeing a preview of what's going to happen. Basically, the tool body in red is going to cut into the target body. So I'm going to click OK and hide the tool body so you can see the cut that happened. Basically, the intersected area is cut away from the target. Okay, going back to Edit Feature, same thing, same selection, same operation. If I don't keep the tool, then basically we have one, just the target, one body. The other body was deleted. And let me go back to Edit Feature and change the operation this time. So now we're going to go down to intersect. So basically what this is going to do is the intersection of these two, let me show them both here. The intersection of the target and the tool body is what the tool body is going to turn into. If I don't keep my tool, let's see what happens. I think I did keep my tool. Hold on a second here. Yeah, if I don't keep the tool, here's what happens. We get a small target body, which was the intersection of the tool and target, and the tool body got deleted. If we go back into that and pick the sixth combination here, intersect with keeping tools, then we still have our two bodies. The tool body will always remain intact if you keep it, and the target body is the intersection of the two. So it's a very powerful feature that you'll use often in woodworking, in particular to create joinery such as dados and mortises. The rectangular pattern feature is another important feature in Fusion, and this can be done within a sketch or outside of a sketch. So first let me demonstrate how to use it inside a sketch. I'm going to create a sketch on the bottom plane here, and I'm going to make a rectangle and size it 2 inches by 2 inches and hit enter. So now I have a fully constrained sketch attached to the origin, 2 inches by 2 inches from my dimensions here that I'll clean up a little bit. Okay, now let's say I want a bunch of these rectangles, which I'm eventually going to turn into cubes. If I double click on this geometry, I've selected it all, And then I can go to Create Rectangular Pattern, and a dialog box pops up, and it says you've already selected 4 objects, which are the 4 lines. I could add to that if I want, or I could click on X to restart that selection, but I'm good to go. Now I'm asked to select a direction. So I click on that. That's now highlighted blue. And let's say I want to go in the existing direction. I don't need to select anything. It's already set up to go horizontally. If I wanted to go in another direction, I would need a line or a plane to do that in. Okay, so now distance type of there's 2 distance types, spacing and extent. Extent means what's the overall length of all of your copies, and spacing means what's the distance between your copies. So I'm going to pick spacing, and if I put in, let's say we're going to do 7 of these. You'll see I now have 7 boxes on the screen, including the original. Okay. Now the distance, if I put in 2 inches as the distance, which was the size of our original rectangle here, there's no spacing in between. So basically this distance is center to center using the selected geometry. So if I want a 2-inch gap here, I would just have to double this and say my distance is 4. Okay, now my direction type, the array of rectangles now is going in one direction. If I want it to radiate out in both directions, I would pick symmetric. And now the original rectangle is in the center, and 3 to the left and 3 to the right. Okay, now you'll also see there's another section here with another quantity, distance, and direction type. So if you want to do a 2-dimensional array of rectangles, you can simply start filling that in. And let's say I'm going to leave that at 3. And the reason we see nothing now is the distance is set to 0. But if I set the distance to 4, you're going to see a preview. So it took this row of 7 boxes and made 2 more copies for a total of 3 going in the upwards direction. And let's say I want to make that symmetric too. So I'll have 1 row above my original selection and 1 below. Okay, so if I click on OK and then Finish Sketch, I now have a sketch with a bunch of rectangles. And if I want to make these all into cubes, I can use my selection tool, select them all, and now we're seeing profiles on all of these rectangles. And I'll go up to Extrude, and Extrude is saying I've selected 21 objects, which was my 7 times 3. So I've got all the rectangles, and now when I extrude, I'm pulling them all up, and I'll type in 2 inches and press enter, and those are my perfectly spaced cubes. If I look at it from the top, you can see, and from the front, you can see that they are indeed perfectly arranged. Okay, so that's one way of doing it. The downside of that is I've got a fairly complicated sketch here with a lot of objects in it. So let's look at another way of doing the same thing. I can go into Sketch. I'll pick that same bottom plane right here, and then I'm going to make the same kind of rectangle here and label this 2 and 2. Okay, now I'm going to finish the sketch right away because I want to create just a single cube and then use the rectangle pattern feature to pattern bodies. So I'm going to press E for extrude, pull this profile up and type in 2. So I now have a 2x2 cube, and I'm going to go to Create, Rectangle Pattern, and now I want to select bodies, and it's asking me to select a body or bodies. I'm going to select this one, and we'll use similar data that we did last time. So direction, If we click on that, I'm going to use this plane right here, if I can get it, right there to establish my direction, which looks like it didn't establish. So I'm going to use the axis line here. Okay, so that worked. I now have a direction. Primary direction is in green. The secondary direction, if we choose to go in a second direction, is in white right now. So we're going to go back to spacing, and we're going to pick 4, which is going to give us a 2-inch gap between the cubes. Oh, I'm sorry, that's distance. We're going to go to 7, and then distance is going to be 4 inches. And again, we're going to do our symmetric, so 3 on each side. All right, and now we're going to go in our second direction. So we'll leave the quantity at 3. The distance is also going to be 4 inches, and the direction is going to be symmetric around the original location. Okay, and then I'll do OK. So if we look at this from the top, you can see the results are identical. They're spaced the same, the cubes are all the same. So now looking at this, you might ask, well, which approach is best? Well, in the first approach, I've got a complicated sketch. If I open this up, I've got 21 rectangles in a sketch. And let's say I want to be able to edit this. There is a way to edit this, which I just discovered recently. You click on this little constraint icon, double click on it actually. That is a rectangular pattern constraint. If you double click on it, you are editing the pattern feature. So if I wanted, a quantity of 9, say, on each side, and let's say I want 4 in the other direction, I can change that, and you can see that the rectangles have updated. So let me finish that. So basically, I would have to go back now to my extrude command, which is here, right click, edit the feature, and we would have to add in these additional profiles to get those to extrude up. So a couple of steps involved to making a change there, and you've got a complex sketch. On the other hand, if we look at this rectangular pattern, if we right click on that in the timeline, we are right in the edit feature, so it's a little bit easier to find and edit the feature. If I want to change the quantity to 9 here or 4 in this direction. So basically the same result, but I did not have to do an extrude. The extrude didn't have to be modified so that these new rectangles are part of it. That's actually back here. If I edit that extrude, 21 are selected. So if I just click on the remainder of those, we can get those cubes to be produced. But you can see this is, this is a little bit of additional work here. So they're both the same now. So I obviously do prefer doing it outside of a sketch. It puts it in the timeline. It's easier to find it. It's easier to edit it. Next, I'm going to demo the fillet command. So I'm going to start by creating a sketch on the ground and making a 6x6 rectangle. I'm typing in 6, pressing tab, and 6 again, and enter. Okay, so I'm going to extrude this up and make a 6x6x6 cube. Okay, now let's say I want to round over the 4 vertical edges. So if I go to my fillet command, or press F, which is the shortcut key, I can simply click on the 4 successive edges that I want. I actually clicked on that face, so I'm going to shift click to unselect that. And that brings up another point. You do not have to shift click once you're in a dialog box for any of these Fusion features. Just clicking will add to the selection. So you can see I've got one face still selected here. I'm not sure where it is. So I'm actually going to start over here. So I'll hit the X, and then be a little bit more careful. So there's one edge, there's a second, there's a third, and there's the last one. Okay, so I have 4 edges selected. I can see that in my dialog box. And then I can push on this arrow key to see, you know, how far I want to fillet something. Or I could just type in a number. If I type in 2 inches, I'm getting a 2-inch radius on that fillet. And if I press enter, the fillet command is done. Now, you can also do a fillet in a sketch, which is a little bit different. You would basically round over the edges of the rectangle and then extrude it into a cube. So I'm going to make another sketch on the same plane, and I'll make another 6x6 rectangle. And this time I'm not going to extrude it. I'm going to stay in the sketch, and I'm going to go to Modify, Fillet, and now I can either click 2 edges like this to get my fillet, or kind of hover over the intersection of these 2 edges, and sometimes you'll get a little red. Actually, when I go to the corner is how it works. If I go to the corner and hover over that, I get this red outline, and if I click, I'll get my fillet going there. So I'm just going to click in all of these corners. Now this defaulted to 1.5 inches. I would like those to be 2 inches. So I'm going to type in 2 here, and I guess they were all set with an equals constraint, so they all became a 2-inch fillet. So I'm going to finish my sketch, and now I can extrude up and then type in 6 inches. So you can see the result was the same, but on the object in the left, in the body in the left, I made the 6x6 cube and then worked on the body itself to fillet the edges. In the one in the right, I modified the sketch and then extruded it once those corners were filleted. So to compare and contrast the 2 methods, I like the first method, where you first create the body. Well, we did a sketch and then we extruded the body. Then we added the fillets to that body. Now, if I want to go back and change the fillet, I can go to my timeline, right click, edit feature, and then let's say we want to go to a 1-inch radius. So I type in 1, and there's my change. Now in the second feature, I want to change this. I'm going to go back to the sketch, edit the sketch, and now I've got to change the radius of all of these. So I'm going to change this to 1 inch. Now they all did update because there was an equals constraint on these radii. So I'm all done now. I'll finish the sketch, and then the extrusion happens, and we're back at the same place. So that's one difference. I think it's a little more difficult, a little less intuitive to have to edit the sketch. A second difference is in this method, I can do fillets in 2 dimensions. So if I want to fillet this top now, I can press F for fillet, and basically I can just hover over the entire top and click. Now, tangent chain has to be on in order to do that, but as long as it is, it's going to basically anything that's tangent to one another, it's going to select all of these curves at once. So now I can push pull. I could set a different round over. Let's say I want 1 inch, or let's say I want 1/2 inch here, something a little different. Okay, so there's no real equivalent here to do it on a sketch. On this side, I'd have to do the same method of pressing F for fillet, selecting the edges, and then typing in the radius. So to do the complete fillet job here, half of it was done in the sketch, the other half was done directly on the body. I think you're better off just always working on a body. It's easier to find in the timeline, and I think it's a little bit more intuitive. The offset feature is pretty straightforward. It works only in sketches. So I've got a little model here that I've started with 4 table legs, and now I want to do a tabletop. So I'm going to use the offset command in a sketch to help me do that. So I'm going to start a sketch on top of one of these table legs, and then get the rectangle tool and snap to 2 outside corners. So there's a tabletop that is parametric to these table legs. If the legs change in size, the tabletop will change in size, or the sketch will change in size, I should say. But what if we want this tabletop to extend beyond the legs? That's where the offset tool would come in. So I'm going to click on offset. I'm still in my sketch, and I'm simply going to click here on the entire rectangle. You'll notice that chain selection is checked here, and that's allowing me to click on any of these 4 sides and get them all selected. Otherwise, if this was unselected, I'd have to pick them all at once. And now I can simply move outward, and you see outward in this case is negative. So let's say I want negative 4 inches as my overhang in each direction, and then press enter. So now inside the sketch I've got another rectangle that's exactly 4 inches out, and I've got 2 profiles to select. So an easy thing to do here is to double click on the inner rectangle and then press the X key to make that into construction geometry, and then I've just got a single profile to click on. So now when I finish my sketch, I can do an E for extrude and pull up the tabletop, say 1 inch thick. Now, if I want to change the overhang, I simply change the offset. And the way you do that is to edit the sketch. And there is a constraint in here, which is the offset constraint. So it appears in 2 spots here. I can double click on either one of those, and it's going to bring up my offset and allow me to edit it. So I could change this to 3 inches, say, and change the offset, finish the sketch, and now the tabletop is changed in size. Another thing you can do with offset is you don't have to pick all 4 sides. Let's say for some reason we wanted the back side of the table to be flush up against the wall, and we don't want an offset there. I'll go back in, I'll edit the sketch, I will double click to edit the offset, and now I'm going to go to my selection and just kill it all, and chain selection is turned off, and now I'm going to pick 3 lines, 1, 2, 3, and do the same offset. And now we can simply draw a line from one side to the other to get our closed profile, finish the sketch, and then it's extruded up. So now we've got a flush back that could be pushed up against the wall. So I just wanted to show you that you don't have to pick an entire rectangle to do an offset. Offsets will also work with any shape. If I create a sketch and then I'll use a spline, for instance. I can come in with my offset tool and offset from that spline. So basically any shape can be offset, as you can see there. So very handy feature, works inside sketches only, and can be edited by double clicking on the sketch constraint for offsetting. Sketch constraints may be the most difficult thing to learn in Fusion. Sketch constraints appear in sketches only. Some of them get set automatically as you're drawing geometry, if there's other things to snap to, for instance, or you manually add constraints to your sketch. So let me start by just demonstrating some of the constraints. I'll create a sketch on the bottom plane, and I'm just going to create a line at an angle and finish that line, and now I'll make a second line Okay, so let's say we want the lines to be horizontal or vertical. There is a constraint here called horizontal vertical. If I click on that and then click on a line, if this line is closer to horizontal than vertical, it's going to go horizontal. Same here. So they are both now horizontal. Now if I hit escape to get out of my horizontal constraint, I'm going to try to change this line. I'm going to grab the end point, but you can see I cannot get it to be anything but horizontal. Contrast that to a new line that has no constraints. And I can grab this point and move it around anywhere. I can't do that with this line because it's horizontally constrained. Okay. Now I'll show you the vertical constraint. Since this line is closer to vertical than horizontal, if I click on the horizontal vertical constraint, this line now, oops, I had a point selected. Okay, this line now will go vertical. And the same thing, I can move this line side to side, I can change its length, but I cannot get it to angle away from a vertical line. So that's probably the easiest constraint to add and the easiest constraint to understand. Now, as far as constraints getting added automatically, rectangle is a good example. If I make a rectangle, so I'm going to click here, come down, click here a second time, and now the rectangle is finished, and you see 4 constraints that were added automatically, 2 horizontals and 2 verticals. So again, if I grab one of these points, I can move that point around and resize the rectangle, but I cannot make its sides anything but horizontal or vertical. And those got added automatically. I didn't manually do that. Okay, now constraints can be deleted and the geometry will react differently when they are. For instance, if I click on this constraint and press the delete key, click on this constraint, press the delete key. Now what I've said is that there's 2 lines in the rectangle that must remain horizontal or vertical. This line does not have to. And I can take that point and demonstrate that. So the top and right sides are free to move around anywhere. But you'll notice that they are always attached. So that's a good question. Why are these lines always attached? And if I hover over a point right here, I see this constraint. And by the way, to determine what a constraint is, you can either look up here, look in your menu, and see, okay, that's the icon for the coincident constraint. Or, even easier, if I hover over it and click, in the bottom right corner, I see that this is a coincident constraint. If I click on this one, it says horizontal constraint. So that's how you determine what things are. The coincident constraint is a little different in that it doesn't appear. Coincident, you don't see it until you click on the 2 points that are coincident. Or if you click on the line, well, if you click on the line, you don't see that coincidence. If I click on the intersection of those 2 lines, I do see the coincidence. So if I was to click here and delete, now those 2 points, the end point of this line and the end point of this line, are no longer coincident. So when I move this top line, it moved away from the other line. Those points are no longer coincident. So if I want to make them coincident again, I can go to my coincident constraint, click on the first one, click on the second one. Let me try that again. Click on the first one and the second one, and so now I'm not honestly sure. Oh, there we go. I guess I wasn't clicking on the point. Okay, so now they are coincident again. If I press escape to get out of my coincident tool, you can see that as I move those sides, they stay in the same spot. Okay, so let's look at some other coincidences. There are parallel coincidences. So if I make a line here and hit escape and make another line, and I want those two lines to be parallel, I can use the parallel constraint. Now, since you're selecting two things here, one of them is going to be parallel with the other. In other words, one of them is going to move and the other one's going to stay put. An easy way to understand that is the first one, if you say click to keep, that's a good way to memorize the fact that the first one will stay, the second one will move. Now, that's not always true. If you have some fully constraint sketches, it doesn't matter the order that you're clicking. If you have fully constrained geometry, it can't move anyway. So it doesn't matter whether it's selected first or not. Okay, so now you may have some differing constraints. Like if I say, okay, I want to keep this one and I want my parallel constraint to now be enforced on this line. Well, this line couldn't move, but the other two could. So they are parallel to each other and they are also parallel to this. So the order of operations doesn't always work out, but if things are free to move in either direction, clicking on the first one will stay where it is and the second one will move, and the constraint will be imposed on the second one. Okay, so getting back to coincident constraints and how this stuff gets added automatically to your sketch. Let's say I make a rectangle and I start it right here at this point. You see a blue rectangle popping up. And when you see that and you click there, you are getting a coincident constraint. So if I click a second time, now if I want to move this rectangle, I can double click to select the whole thing. And if I try dragging it, it's dragging the other rectangle with it because I made this point coincident with the upper right point of the new rectangle coincident with the lower right corner of the existing rectangle. And I didn't do anything there except hover over it and basically snap to it. So if you want to delete these coincidences, there's two ways to do it. You can see that you can click on a coincidence and hit delete. All three of the coincidences deleted themselves. Let me undo that. So now they're back in there. And the reason that there are three coincidences here is the end point of this line, the end point of this line are coincident, and the end point of these two lines are coincident, and those intersections of the two rectangles are coincident. So that's the three coincidences here. And like I said, if you select any one of them and delete it, all three will be deleted. Another way you can delete coincidence is to click on a line, right click, and go down to delete coincidence. And let's see, if I click on this other line, I go down and delete coincidence. So that gives you a little bit more control. In this case, there's at least three to delete. Let's see if I need to delete four. Okay, so there was four. So now if I double click on this rectangle, I should be able to move it away from the other rectangle. But I had to go in and manually delete each coincidence from each line. So those are the two methods of getting rid of those. Now, since I'm moving this rectangle around, let's see what happens if I take this point. Well, I actually lost my coincidence in the rectangle itself. So first I'm gonna kind of heal this rectangle. I'll go up to coincidence here. I've got a line selected, so I'll press escape first. Click on coincident constraint. Click on this point, so that should stay put. Click on this point, that moves to it. So now, when I hit escape and select my rectangle again, let's see if I hover over this point. If I drag this point around, the other sides are following, which is what I want. So let's say I want this point to be coincident with this point right here. Two ways I can do that. I can move it up, and if I see this blue rectangle or blue square pop up, I know I've imposed a coincident constraint. So if I release that, double click to get this rectangle and move it, you see I established one coincidence here. I think this other one was broken. So if I undo, let's see, yeah, these two lines are not coincident yet because we went in and deleted all of those. So let's say I want this one to stay. So I'll click on coincident, click on this point, click on the second point. So now, after I hit escape and I double click, or I drag this point, I'm getting both lines at the same time. Okay, so now I'm in a position to do what I wanted. I'll double click here, I'll grab this point and deposit it right there. And now when we double click to drag this rectangle, it's not doing what I want. So let's try the second method. I tell you, the coincidences are a challenge. So I'm going to select this point right here and go up to coincidence and then select this point. Now I'm hopeful that when I drag this rectangle, the other one is coming with it. So that's some in-depth on coincidence. Other constraints that are useful, midpoint, especially useful. Let's say I want to position this line to the center of this line. I can use a midpoint constraint for that. So with nothing selected, I'll go up to the midpoint constraint and I'll say the midpoint of this line is coincident with this point right here. And that point comes down to the midpoint. Now let's say I want the midpoint of this line to be in the midpoint here. I can click on the first line and the second line, and this horizontal line was free to move, so it moved down to the rectangle, and the middle of its line showed up here. Those are examples, valid examples, but generally not something you'd be doing a lot. Generally, I'm in a situation where I have two rectangles and I want to center one rectangle potentially inside another rectangle, or I want to center one rectangle right above another rectangle. So let me make this a little bit smaller. And basically, I want to center this rectangle right on the top here. So I could easily say I want this midpoint to be on this midpoint. That would work. So I'm going to say, okay, I want to click to keep this midpoint. And what happened there? It went over. Let me undo and try to understand what happened there. I didn't have anything selected. So I'm saying, okay, the midpoint of this rectangle should align with the midpoint of this rectangle. And it does, but one rectangle moved that I didn't anticipate moving. I thought the first one, oh, did I do that right? The first one did stay. Let me undo here. The first midpoint is going to stay. Second midpoint is going to move. Okay, that makes sense. All right, what if I now want this smaller rectangle to be centered within this rectangle? Well, one way to do it is to add some diagonals and use that as construction geometry. So if we go to the line tool and we pick construction, or you can just press X, these lines are going to be dotted. So these lines won't let you they're not useful for extrusion. They don't create a closed profile, but they can be used to do stuff like create a point. Like right there, I have a midpoint. So I could align that midpoint to a midpoint down here. So I will continue to make some construction lines here from corner to corner. And then once I have that intersection, I also have a midpoint here. So what I want to do is I want to see if I can get my midpoint here. So I go to my midpoint constraint and I don't see anything there. So what I'm going to do is go up to create and manually put a point here at the intersection of these two lines. And I will manually put a point here at the intersection. And now I'm going to say I want this point to move to here. So I can do that with a coincidence. Click on this center point first, because that's going to be the one that will stay, and this one second, and now my rectangle aligned within the other rectangle. Okay, so midpoint is not particularly useful itself, but is used for doing some stuff like that. If I want a line like here to be coincident with a midpoint right here, I can go to my coincident constraint and click on that and hold down my shift key. And when I hold down shift, then I see a midpoint here. So that's what I want to select, the midpoint of this vertical line and right here. So now the horizontal line moved down to the midpoint of the vertical line, but that midpoint was only exposed by holding down shift and then hovering over the midpoint. So midpoint is used, I use midpoint a lot more for that than anything else, than using the straight midpoint constraint. If we go to circles or curves, we can impose some tangency. I'm still in construction mode here, so I'm going to press X to get into real geometry. Now, if I have a line that I make out in space, I'm still in construction geometry, so let me turn that off in the sketch palette. And I'm going to click on this and press X to get rid of the construction geometry. So now I want this line to be tangent with the circle. So if I click on tangent, I click on the circle, that's what I'm going to keep. The line was already pre-selected, the line moved into the circle. Now if I move the line around, you can see that I can change the point that's intersecting with the circle, but it's staying tangent to the circle as I change the angle of the line. So tangency, not used a whole lot in woodworking, maybe in some fancy curves you might use it, but certainly in things like guitar making, tangency is very important. Okay, so symmetrical constraints. Let's say I'm making a profile of something that I want to create half of it, and then I want the other half to be very similar to it, or actually identical to it. So if I let me start with a vertical line here. And I'm going to turn that into construction geometry. So I click on it and press X. And now if I make a horizontal line, I'm going to press X again to get out of construction mode. Oops, still in there. Okay, so I make a horizontal line this way. And let me make a curve going back, an arc going back to the construction point. Well, that's not arc. Let me make a spline. So I'm going to click here, and then I have these handles that I can define kind of what the spline is doing here. So what I want is I want a symmetrical drawing. So I can do one of two things. I can mirror this to the other side, but I also want to make it symmetrical with the other side so that when I change these spline handles, the identical thing happens on the other side. So first let me mirror it. I'm going to select these two sketch lines. So I clicked and shift clicked. I'm going to go up to mirror, and it shows that two objects are selected. So I'll click on the mirror line, click on this vertical line, and now you see it's mirrored on the other side of my construction geometry. So I'll click OK. And by doing so, I have imposed these symmetrical constraints. And you can see there's a bunch of them all over the place. So what this is doing is saying, well, if you change your handles of your spline on either side of the object, both sides are going to react the same. If I was to be able to change the width of this line on one side of the symmetry line, both of the sides are going to change because of all of these symmetry constraints. I honestly can't tell you why there's so many of them. I think there's symmetry constraints on, let's see, there's one on this point, which probably appears over here, and then there's one on each end of the tangent handle for the spline, which appears over here. Same up here. So I think, you know, this symmetry is being shown here and here. That's why you see so many symmetrical constraints there. And if we were to delete these, I'm not sure if they'd all go away at once. Let's see. If I click on one of them and delete, no, I'm actually going to have to go through and click on each one of them to get rid of all of this symmetry. But let's just click on a few and test my theory out. So now if I move this tangent handle, they're still both doing the same thing. If I move this tangent handle, they're both doing the same thing. If I move this line, now that line is no longer symmetrical with the other side because I had deleted its symmetry in this essentially list of symmetrical constraints. So that'll get you started in sketch constraints. I think by far the most useful stuff is to automatically snap to something. You know, if I'm starting a rectangle right here, and then I automatically impose a coincident constraint. So I think it's nice to be able to impose your constraints as you're drawing. But you will see, a lot of times if you watch other Fusion videos, you will see guys who want a rectangle to be in a certain spot, and they will draw that rectangle away from the spot and then say something like, well, now I'm going to impose a collinear constraint, for instance, right here, and say, okay, this line is going to be collinear with this line, and now the sketch constraints is imposed. Whereas if you tried to do this by hovering over it, sometimes you get the right constraint, but sometimes it mistakenly puts in something that you didn't want. So that's an intro anyway to sketch constraints.